Welcome to day 3. We're going to work on properties of logarithms. So we talked about logarithms last class, kind of how they're finding these exponents. So just like we had on day 1, properties of exponents, we're going to have properties of logarithms. They're going to be very similar. So these properties that we're going to work on, they work in both directions. And the idea is that when we do this, we have to have logs. The logarithms that we use have to have the same base. You can't work with logarithms that have different bases. It wouldn't work. So the first property you're going to look at is that it's called the product property. In other words, when we add logarithms, we can multiply the quantities that you see with the logarithms. Okay, and it works both directions. So when I have log of 2 plus log of 3, I'm adding. So 2 and 3 can be multiplied together, and I get 6. Or log base 5 and log base 5, log base 5 of 2, log base 5 of x. 2 and x are multiplying each other, you get 2x. But it does work in the reverse direction. When I have log base 8 of 64x, I can split it up into 64 times x, or split it into 2 logarithms, log base 8 of 64 plus log base 8 of x. See, when I multiply, I add. When I add, I multiply. The next property is called the quotient property. So when I subtract logarithms, I can divide those quantities within the logarithms. And the other way around, so you can see when log of 50 subtract log of 2, I am dividing 50 over 2 and I get the log of 25. And the other way around, when I have the quantity x over 8, so log base 8 of x over 8, I can make it into a subtraction of 2 logarithms. Okay, when I go from multiple logs down to 1, that's reducing or condensing. Another one is expanding. And here's a property that we're going to use a lot, not so much today, a little bit today, but a lot when we start solving. And the idea is that this exponent on that a can become the coefficient in front of the logarithm. So this exponent can go in front, and vice versa. This coefficient in front can become the exponent. So this 1/3 can go here and become x to the 1/3, or the cube root of x. And the same thing here, this log of x squared, this 2 can go in front and becomes 2 log of x. This is going to be big ideas. And then the last property we're going to have is this change base. I don't know how much we're going to use it today, but the idea is that, let me pick another color, that the new calculators you could use any base. And I'll bring the calculator up in a minute, but the idea that I could have any base I want and I could still figure out what its value is. The newer calculator has this, and I talked about this earlier, underneath the math key. If we go to the letter A, it says log base, and we could type that in. I'll show you what I mean. So we talked about last class, this whole right here, log base 2 of 8 is equal to 3, because 2 to the 3rd is equal to 8. That 3 is the exponent. If I use my calculator here, I can just do, I can go to the math key, move it up to A. I have that special key. Most new calculators have this. I can make the base 2. I can make the value 8. And it equals 3. Log base 2 of 8 is equal to 3. But I could just use this general log key and do log of 8 divided by log of 2, because they're using the same base. In this case, both bases are 10. I still get 3. Or I could do the ln key of 8 divided by the ln of 2. Again, they're the same base. They're both using base e. I still get 3. Or you can use any base you want. Let's use base 5. So you can see I typed in log base 5 of 8 divided by log base 5 of 2. Same bases. It's basically 8 and a 2. I still get the result of 3. And it wouldn't matter what I would make the base as long as I make them the same base. So for the same example, I've just used a different base. I made both bases 3.25. As long as it's a positive number that isn't equal to 1 or 0, you can use any base you want, and I still get the result of 3. So you can see all the little examples I did. It shows you they all work out the same. Even if I did log base 5 for both of them, I did another example here. It doesn't really matter as long as you're consistent. It's all going to work the same. Newer calculators, you can use that special key, the log base key. So today, our point is going to use these properties to rewrite things, because our purpose today is really going to be to simplify. But tomorrow, we're going to use these properties to rewrite things so we can solve. Today's going to be about simplifying, tomorrow's going to be about solving. So for this first example, I'm going to expand it out into multiple logarithms. I see multiplications going on, so I can split it up into 2 logarithms. Log of x squared plus log of y cubed. When I multiply quantities, I can make it into addition. And then these things can flip up front. So I get 2 log x plus 3 log y. That would be expanding it. Same thing here. I see multiplication going on here. And 2 is multiplying x, so it becomes ln of 2 plus ln of x plus ln of y. As you see, I'm multiplying 3 things. So I'm adding every single time. The next example, I see some division going on. So when I do the next one with division, it's going to be, don't forget this base 5, log base 5 of x squared minus, because of the division, log base 5 of y. Don't change the base. And then this 2 can go up front. And I get 2 log base 5 of x minus log base 5 of y is my final result when I expand it all out. In this last example, I see some multiplication going on. I see some division going on. So I get ln of 3 plus ln of the square root of x minus, for division, ln of y to the 4th. And when I see the square root of x, it's really x to the 1/2. And this 1/2 could jump in front as a coefficient, and this 4 could jump in front. So my final result is ln of 3 plus 1/2 ln of x minus 4 ln of y. And that is my final result. That is expanding, taking one logarithm and splitting up into many. Now I'm going to go the other way around. I'm going to condense it. I'm going to get down to a single logarithm. So I see this 3 coefficient can come be the exponent. This 2 coefficient become this exponent. I'll worry about this subtraction later. So right now I have log of k to the 3rd minus log of k plus 3 squared. And now when I see this division, the subtraction, I could rewrite it as a division, log of k to the 3rd over k plus 3 squared. That whole result, that k plus 3, remember this is not the only time I use my rules of logs is when I'm subtracting logs or adding logs. This is not adding of a log, that's just k plus 3. The next example, I see, oh, this guy can go here, and this guy can go here. So I get log base 3 of t to the 4th minus log base 3 of w to the 1/2. And if you want, you could say log base 3 of t to the 4th over w to the 1/2. That's one way to write it. Or you could say log base 3 of t to the 4th over the square root of w if you want to rewrite the square root of w from w to the 1/2. To me, they're the same. I wouldn't take off for either one. Okay, I see some coefficients I'd have to move. So ln of 2 plus ln of x to the 1/3 minus ln of y to the 4th. I see some addition and subtraction going on. So I'm going to rewrite it as ln of 2 times x to the 1/3 over y to the 4th. And if you want, you can rewrite it as ln of 2 cube root of x over y to the 4th. And that would be your final result. You could keep it the other way with the fraction exponent. It wouldn't make a difference to me. Again, I see some coefficients that have to become exponents. I get log base 5 of a squared minus log base 5b to the 4th minus log base 5c to the 3rd. And I see I have log base 5. I see subtraction, which means I want to have division. A squared, b to the 4th, and c to the 3rd is also dividing, so I could put them both in the denominator. And there we go. There's your final result. I wouldn't write it as a double fraction. Doesn't matter if you both b to the 4th and c to the 3rd will be dividing because they are subtracting logs. So this next page is based on the idea that x is log of a, y is log of b. I'm going to use substitution. Every time I see the log of a, I'm going to put down x. Every time I see log of b, I'm going to put down y. So when I see this problem, since this is multiplication going on, I could rewrite it as log of a plus log of b, because when I multiply a and b, I can split it up into two logs by addition. And then I can use my substitution that log of a is x plus log of b is y, and I get x plus y as my final result. This one I could split up. I see log of a cubed plus log of the square root of b, but the square root of b is really b to the 1/2, and I have some exponents I can move in front. So I get 3 log a plus a half log b, and again I see my substitution. I can get rid of log a and log b and write it as 3x plus 1/2 y. So that's rewriting things in only terms of x and y. This next one, C, is a little bit easier. I can say, well, I have division, so I can rewrite it as log of a minus log of b. And I can get rid of log of a and make it x. I can get rid of log of b. I can do minus y, x minus y. My final solution. Now this one's a little bit difficult, a little bit different. I have x equals log of a. Remember, there's a 10 here. That's this base. So when I curl this, I get 10 to the x is equal to a. And when I do the same thing with y equals log b, there's a 10 here, and I curl this, I get 10 to the y is equal to b, and now these are my substitutions. So a becomes 10 to the x times b becomes 10 to the y, and I know that when I multiply, I add exponents, I get 10 to the x plus y as my final result. Again, I'm going to work with the substitution idea that every time I see log of 2, I'm going to put in the letter A, and every time I see log of 5, I'm going to put in the letter B. So I have to rewrite things using 2's and 5's. So when I see the decimal 0.4, log of 0.4 becomes log of the fraction 2 over 5, but since I'm dividing, I can split it up into subtraction of the numbers log of 2 minus log of 5, and then log of 2 becomes A, and log of 5 becomes B, and I get the whole thing A minus B. So for this one, I have to think about 40. How can I rewrite 40 as 2's and 5's? Well, 40 is 8 times 5, which is the 2 to the 3rd times 5, so I could rewrite this problem as log of 2 to the third times 5, and then I can split it up. Oh, well, I see multiplication, so 2 to the third plus log of 5. This 3 goes in front. I get 3 log of 2 plus log of 5. And my substitution says log of 2 becomes a plus log of 5 becomes b, and I get a final result of 3a plus b. Over here, I have to think about 0.25. Well, 0.25 is 1 over 4, which is 1 over 2 squared, which is 2 to the negative 2. So I can rewrite this problem as log of 2 to the negative 2. And I know that this exponent jumps up front, so I get negative 2 log of 2. And by my substitution rule, log of 2 can be rewritten as negative 2 times a. So how to think about the square root of 10? Well, the square root of 10 is really the square root of 2 times 5, which is really 2 times 5 raised to the 1/2 power. So I could rewrite this problem as log of 2 times 5 raised to the 1/2. And I know that this 1/2 jumps up front, so I get 1/2 log of 2 times 5. I see multiplication, so I could rewrite it as 1/2 log of 2 plus log of 5, because when I multiply, I can split it up into addition. And then again, by my substitution tricks, I get 1/2 a plus b as my final result. If you want to distribute it and say 1/2 a plus 1/2 b, that's fine by me, it's all the same. Now this last one is going to be the trickiest one to all, because you're making a conjecture. You're saying, how does this work? Because it's not exactly, see how it says approximately equal to? It's not going to be exact. So how can I show that it's about the same? Well, this is playing with number theory a little bit. I know that the log of 7 is equal to the log of the square root of 49, which is about the square root of the log of the square root of 50. Square root of 49 and square root of 50 are going to be about the same. Well, this is just log of 50 to the 1/2 power. I know this guy's going to jump up front, so I have 1/2 log of 50. Well, for me to break up 50 is 2 times 25, which is 2 times 5 squared. So I could rewrite this as 1/2 of the log of 2 times 5 squared. Well, if I split it up even more, I could say it's 1/2 log of 2 plus log of 5 squared. Oh yeah, I remember that this 2 drops up front, so I can get rid of the 2 here and say it's really 1/2 times log of 2 plus 2 times the log of 5. And by my substitution rules, this becomes 1/2 parentheses log of 2 is a plus 2 times log of b. 2 times b. And that's exactly what I'm looking for. So it's a little bit of manipulation saying that the square root of 49 is about equal to the square root of 50. Why 50? Because I'm playing with 2's and 5's, and with 50 I can get to something that multiplies by 2's and 5's.